Okay, so this is May 2025 paper, Unit 1. In question number 1, they are saying which row shows the number of neutrons, electrons in a bromide ions. Since they have given you the mass number, that is 79, can you tell me the proton number after looking at the periodic table? What's the proton number for bromine? So it has a -1 charge, so proton number +1. Of course, it has gained one more electron, right? So what's the proton number for bromine? I think it's 35. I think it's 35, isn't it? Yes.
Yes, sir.
So 35 plus 1, its mean is equal to 36. So it has 36 electrons. So 36, 36, we have two options, B and D. So how many neutrons it would be having? 79 minus 35. What's the answer? 79 minus 35. It's gonna be 4 and 4, 44, isn't it? So the answer is B, right? Then they are saying what volume of sulfur dioxide gas reacts completely with 50 centimeter cube of 0.12 mole per decimeter cube sodium hydroxide solution. So since the volume and concentration is given to you, so I can find out the moles first. So the mole would be equal to mole of sodium hydroxide would be equal to concentration, that is 0.12, multiply the volume. It should be in decimeter cube. I am going to divide it by 1000 to get the number of mole of NaOH, right? So then after finding out the number of moles of NaOH, I can apply the mole ratio between SO2 and sodium hydroxide. That is 1 is to 2. It's 1, it's 2. Okay. Then I have to know the mole of SO2. It would be X. Then I have to cross multiply this. I would be getting the number of moles of SO2. After getting the number of moles of SO2, okay, mole of SO2, then I have to find out the volume. So volume would be equal to mole multiplied by 24. So I would be getting the volume in decimeter cube. Okay. What's the answer for the mole of sodium hydroxide? Yes. What's the answer for the moles of sodium hydroxide? Yes.
0.006.
0.006. This is 0.006. So what's the answer for the mole of SO2? Yes.
0.003.
0.003. So 0.003 multiplied by the 24. What's the answer for the volume in decimeter cube?
0.072.
0.072
0.072.
means A is correct. Okay, good, good. Which amount does not have a mass of approximately 6 grams? Okay, 6 grams. So I have to find out the mass. Of course, mass is equal to Mr. Moles. Mass is equal to Mr. Moles. So I can say that MR is 18, mole is 0.33. So for this one, mass is 24.3, mole is 0.25, and for this one, mass is 180, and the moles are 0.033, and for this one, MR is 159.6, and the moles are 0.025. It's gonna give you the mass in grams. So which option is not going to give you 6 grams? That would be your answer. It's very easy.
Sir, can you explain again?
Okay, basically in this question, they are asking to find out the mass. Okay, so what's the formula for mass? Mass is equal to mr multiplied by mole. They have given you mr, 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 and also they have given you mole, 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 isn't it? So what I do, I'm going to apply this formula. Mass is equal to mr times moles. So I have to multiply just like this. They are saying which amount does not have a mass of approximately 6 grams. Can you tell me the answer of all the options? Then I would see yes, past. What's the answer?
Sir, 2 minutes. Sir, it's D.
D. In D, you are not getting 6 grams, isn't it?
Yes.
Okay. So, so if I'm going to calculate option A, it's 18 times 0.33. It's gonna be 5.94. Okay, so that would be our answer. Are you getting this question? Yes or
Yes,
no?
sir.
Okay. How many molecules of H2O are present in one drop of water? They have given you the volume of the one drop, that is 0.050 centimeter cube. Like, let's say if you will be doing this question, so how you will be starting this question? Like after reading this question, what the thing will come in your mind? Like which formula you are going to apply?
Sir, number of molecules mole into N, A, and then
Okay.
we're gonna find moles, and we're gonna multiply by the Avogadro constant.
Yeah, exactly. So I can say that number of molecule is equal to mole multiplied by Avogadro's number, that is 6.02. They have given us the volume. I can divide it by 24,000 centimeter cube to get the moles, and then I have to multiply this with the Avogadro's number to get the number of molecules. So the answer is D for doctor. Okay, got it?
Yes.
Okay. Then which mass of fertilizer contains 467 gram? Again, the same question. Again, the same question. They are asking the mass, which is going to be 467. So you have to apply the same formula. MR, that is 85 times moles. Okay, but they haven't given us the Like I can say the mole. They have given you the kilogram. What they have given you? Kilograms. So mass upon MR. Mass upon MR. Then first of all, you have to find out the moles. First of all, you have to find out the moles, and then you can find out the mass of nitrogen. Remember. So how you will be doing this question? Just think about it, then I'm going to tell you.
So we're gonna find the moles of the NaOH compound,
Okay.
and then maybe cross multiply with
Mm,
nitrogen.
okay. So to get the moles of nitrogen, then we are gonna multiply with the mass of nitrogen, like MR of nitrogen. So I would be getting the mass of nitrogen. So in which option, when I would be finding out the mass, so I would be getting the answer 467 grams of nitrogen. This is the question that we have to do, right? So let's say, like I'm going to solve option A, right? I'm going to solve option A. So I can say that um, in nitrate, there is only one nitrogen atom. I'm going to write down the mass of nitrogen divided by the total mass multiplied by the given mass. That is 2. Of course, I have to convert it into the grams. So I'm going to multiply this by 1000. I would be getting this one, 2000. Can you tell me the answer for this one? But fast. We are having short time. Fast. Yes. What's the answer?
Three
Then
to
for
nine
this one,
point four.
329. Okay. Then I'm going to solve it. We have two nitrogen atom. I'm going to write 28 divided by the total mass, that is 60, multiplied by 1000. Then I'm going to solve the C as well. The mass of nitrogen, that is 28 upon total, that is 80, times the total, that is 1000 again. Then for D, I can say we have two nitrogen, that is 28, divided mass, that is 132.1, multiplied by the total, that is 1000. So yes, in which option you will be getting 467
Sir, what
grams.
is 14?
Sorry,
What is 14?
what what is 14? What are you asking?
Sir, which formula you mass over MR?
Basically, you know, uh, if you remember when we used to find out the percentage of any substance in a compound, so we used to apply the formula mass over total multiplied by 100. Like if you want to find out the mass of nitrogen in ammonia, so you can do this one. So I'm going to do the same thing. I have to find out the mass of nitrogen. So nitrogen is on the top. Nitrogen is on the top, divided by the total, multiplied by 100, but the mass is given, so I am supposed to multiply by the given mass. Then again, I'm going to do the same concept with the option D. I'm going to do the same thing. We have two nitrogen in this formula. Two nitrogen means 28 divided by the total multiplied by the 1 kilogram. I'm going to convert it into grams. It's gonna be 1000. Okay.
Yes, sir.
Yes. So you can do this one. So of course, in option B, we are getting 467 grams. That's the answer. That's the answer. Then question number 6, which is the correct order for the processes in a mass spectrometer? So basically in a mass spectrometer, we first vaporize the sample, then we ionize the sample, then we would be having a deflection, and then we would be having a detection. Of course, the answer is B. Which of these molecules are polar? So in for this question, question number 6, you need to know the processes of mass spectrometry. If you know the process, so it would be very easy for you. There is no concept behind this. There is no concept behind this. You must know the procedure, how to do mass spectrometry. Like what do we do first, then what we are supposed to do in the next, then what we are supposed to do in the next. Of course, it's a memorization. So then you can see question 7. Which of these molecules are polar? Which of these molecules are polar? So polar means that HCl, which is going to be H partial positive, partial negative. Okay, because chlorine is more electronegative, right? And also, it may be beryllium chloride as well, right? It may be beryllium chloride as well, but the thing is that beryllium chloride is this one. It's a symmetrical molecule. The dipoles are going to cancel each other, so it's non-polar. It's very important concept. You know, most of the students think that, sir, you told us that if we have a different element, so we would say that the compound is polar, and if we would be having a same element, so then we can say that the compound is non-polar. But the thing is that you need to know the given structure, what the structure is, because a lot of things are depending on the polarity, not only one thing, of course. So let's say if I can ask, what do you mean by carbon dioxide? Is this polar or non-polar? So you will say carbon dioxide is non-polar. You know why? Again, same goes for the carbon dioxide. It's going to be like that. So again, I can say it's a linear structure in which the dipoles are going to cancel each other. So completely overall this is non-polar, right? Completely overall this is what? This is non-polar. Even it has a different elements, but we have to consider the structure, right? So then I can say, what about the boron chloride? So it's gonna be like that. Again, it's a symmetrical structure. Again, it's a symmetrical structure. They are going to cancel each other. So I can say that it's also non-polar. So that so therefore only A is correct, because A is the one which is polar. Because in HCl we have two elements. They are not going to cancel each other. Chlorine is more electronegative, hydrogen is less electronegative due to the difference in electronegativities. Due to the difference in electronegativities, they are going to have a charge. Okay, so whenever the examiner would be asking about the polarity, whenever the examiner would be asking about the polarity, so we have to consider, like after drawing the structure, then you have to see whether the compound is symmetrical, or I can say unsymmetrical, right? So that's why option A is correct, in which only HCl is polar. Then they are asking which substance doesn't exist as a giant lattice. So giant lattice, we know that all ionic compounds have a giant ionic lattice structure, and covalent compounds are also having a giant lattice structure, but we have three only: diamond, graphite, silica. Okay, and also metals also have a giant metallic lattice structure. This is metal, it has a giant. This is ionic, it has a giant. This is Buckminster covalent, but it is not a giant. So means that D is correct, because they were asking which substance does not exist as a giant lattice structure. That's going to be D only. Because C is a graphite, and graphite is also a giant covalent structure, right? So sometime you need to have some sort of information, and sometime you have to apply the concept. It's a mixture. Like you have seen in the previous question, they were asking about the mass spectrometry. So what they did, there is no concept. If you know the steps, so you can write down. Which method for the preparation of hydrogen has the highest atom economy by the mass? So, economy by mass. What is this? What is this economy by mass? In this question, you are supposed to apply the formula. You are supposed to apply the formula if you know the formula for the atom economy. If you know the formula for the atom economy, right? So we can find out the atom economy. Let's say, I'm going to solve option A, right? In which I have 2H2 because they are asking about the atom economy of the hydrogen. That's why I have to see only hydrogen. Remember, okay? So 2H2 means that it's gonna be 2 twos are 4 divided by, okay, uh, divided by the divided by the reactant. It's gonna be H2O is 18 times 2, that is 36, and multiplied by 100. Then I'm going to solve B as well. 3H2 means 6 upon the total mass of the reactant side. That's gonna be CH4 is I think 16 and plus 18. So I can this one multiplied by 100. Then I'm going to solve C as well. 2 upon CO plus H2O. CO is 12 plus 16. 12 plus 16 plus water is 18 multiplied by 100. Then I'm going to solve D as well. 6 upon the total 18 plus what's the MR of CH3OH? I don't know what's the MR of CH3OH, but you need to write it down, then multiplied by 100. Then you have to solve all. So the one in which you would be getting the highest answer would be your correct option. That's gonna be B. Okay. So I told you the method you can apply. You can directly put the MRs and then you would be getting your answer. Since simple, it's very simple. Okay. So in this question, you don't need to know about the atom economy. In this question, you need to know about the atom. Again, you can see the atom economy question. I'm going to give you only half of the minute. You can think about it and then you can tell me the answer. Then I would be solving it. Then you can match. As I told you the concept of atom economy first. Okay, so basically in this question, they are saying which reaction to produce copper nitrate has an atom economy of 46.5% by mass. Okay. In all the reactions, copper 2 nitrate are produced. Copper nitrate, copper nitrate, copper nitrate, and copper nitrate, right? So we have to check it all. We have to check it all so that in which reaction I would be looking at the highest, sorry, the given atom economy, that is 46.5%, right? So I can say that like I'm going to opt this one because this is my subject. I have to see only copper nitrate. Okay, MR of copper nitrate is 5. MR of copper nitrate is 187, sorry, 0.5 divided by the total. Copper is 63.5 plus HNO3 is 63 multiplied by 100. You have to do this thing with all B, C, and D. Okay. So the one in which you will be getting 46.5, that would be your correct option. That is B. Uh, that is B. I think so. Let's say I'm going to I'm going to just write it down, then you can check it. Okay. I'm going to just write it down, then you can check it. So copper nitrate, again, it's 187.5. It's again 187.5, right? Or we can say that divided by the copper and platinum nitrate. I don't know the MRs multiplied by 100. I'm going to write down the elements, right? So you can check that. That's gonna be good. So when you will see the paper, so you will understand that what we were doing in the class. So copper nitrate divided by the 2 copper plus platinum nitrate 4 multiplied by 100, right? And then I can say for this one, the same thing for this same thing. The one in which you will be getting 46.5 would be your correct option. Okay. Or what is the maximum volume of butane which will completely burn in 130 centimeter cube of oxygen? Yes. What do you think about this question? By the way, this question is very baby question. It's very easy. Just try to solve it. Then I'm going to tell you.
So we'll use the mole formula.
Okay, you can use it. And then what would be the answer? Okay, let me tell you this one. What is the maximum volume of butane? They are asking about the volume of butane. That is this one, right? And they have given you the volume of oxygen. Yeah, oxygen. So C4H10 and O2. It's 1 and it's 6.5. If the volume of oxygen is 130, so what would be the volume of C4H10? It's gonna be X. So what's the answer for X? Yes. What's the answer for X? Fast.
20.
20. So C is your option. So means that you did 6.5 X is equal to 130. So X is equal to 130 over 6.5. Now see this one. This question is also very easy. They are talking about the empirical formula of a compound. So of course, we can say that they have given you the mass of carbon dioxide and also the mass of water, right? So what you are supposed to do, you can find out the mass of carbon by carbon dioxide. You can find out the mass of hydrogen by mass of water, and then we can find out the mass of oxygen. Then after finding out all the masses, then we can find out the moles. Then after finding out the moles, we can find out the simple mole ratio to get the empirical formula. Okay, to get the empirical formula. So let me solve it. I can say that 3.50 gram sample of an organic compound will completely burn, forming 5.15 gram of carbon dioxide, right? So I can say that to find out the mass of carbon is equal to 12 divided by the total mass of carbon dioxide, that is 4, and multiplied by the given mass of carbon dioxide, that is 5.15. Okay, it would give you the mass of carbon, that is 1.40 grams. Then I'm going to find out the mass of hydrogen. Mass of hydrogen, that is going to be, in water we have 2H divided by the mass of water, that is 18, multiplied by the given mass of water, that is 2.11, equal to, it would be giving you the mass of oxygen, that is 0.234 grams. Okay, 0.234 grams. To find out the mass of oxygen, what we are supposed to do, mass of oxygen is equal to, this is the total mass of a compound. Going to subtract from the total mass. 1.40 plus 0.234 will give you the mass of mass of oxygen, that is 1.7 grams. In this way you can find out the mass of oxygen. Okay, after doing this, you can apply the same thing that you have learned in IGCSE, the same thing 100%. So what I am going to do, CH, then O. Then I'm going to write down the mass of carbon, that is 1.40. For hydrogen, it's 0.234. For oxygen, it's 1.87. I'm going to find out the moles. I'm going to divide it by the atomic mass of carbon, then hydrogen, then for oxygen, I would be getting the moles. I would be getting the moles. For this one, I'm getting 0.117 moles. For this one, I'm getting the same number. And for this one, I'm getting 0.117 again. So what we are supposed to do, we have to find out the simple mole ratio. I'm going to divide it with the smallest number, that is same, 0.117, 0.117, 0.117. After division, I would be getting 1, I would be getting 2, I would be getting 1. So finally, the answer is CH2O. This is an empirical formula, so that's why option A is correct. In this way, you can find out the empirical formula of a compound when the mass is given to you. Otherwise, we have other questions as well in which we are supposed to do less working. We are supposed to do less working, but in this, the mass is given to you, so that's why we did this all things. Which type of reaction occurs when alkane is cracked? Alkane is cracked. What is cracking? Cracking means when something is going to break down in the absence of oxygen. When something is going to break down in the absence of oxygen by the presence of heat. So it's called thermal
Number.
decomposition. It's called what? Thermal, exactly, thermal decomposition. Hairdressers use solutions of hydrogen peroxide that have these hazards, can cause serious eye damage, is harmful if swallowed, is an oxidizing agent. Which hazard symbols should be on containers of this solution? So you need to memorize, of course. So this is for the toxic one, right? Like corrosive in nature, right? And harmful, oxidizing agent. So means that it should be A. Means it should be A. So this is the symbol for corrosive. So damage. It causes damage to skin when you are going to touch it. Then they are saying when hydrogen peroxide is used in an experiment to measure the rate of decomposition, how could the risk be reduced? Using an alternative method that involves less hazardous materials by working on a smaller scale, taking precautions specific to the hazard. Basically, um, how could the risk be reduced? The thing is that by working on a smaller scale, of course, you can reduce the risk. Like they have told you about the hydrogen peroxide. What are the possible risks about like after using hydrogen peroxide? So you can work on a smaller scale, of course. When you will be working on a smaller scale, so you will be having a lesser point of contact with hydrogen peroxide. And then you can take a precautions before going to do an experiment. Like you know the hazards of the hydrogen peroxide, so you can take accordingly the precautions before going to do an experiment, right? So yes, I can say that 2 and 3 is correct. So means that 2 and 3 means option C is correct. 2 and 3 means option C is correct. One molecule of a hydrocarbon is cracked to form two molecules of ethene. Like two molecules of ethene means C2H4. Two molecules of C2H4. Okay. Two molecules of C2H4. Two molecules of propene. Okay. Two molecules of propene, that's gonna be C3H6, and one molecule of propane, that's gonna be C3H8. What is the molecular formula of the hydrocarbon? So it means that I can say 2 to the 4 carbon atom, then we have 6 carbon atom, then we have 3. So 4 plus 6 is 10 and 10 plus 3 is 13. So we are supposed to have 13 carbon atoms. So 13 is only one option, that's gonna D. Yes, this is easy. How many hydrogen atoms are in 14 grams? Oh my God, it's very easy question. How many hydrogen atoms? So first of all, we have to find out the number of atoms. Number of atoms are equal to mole, that is 14, divided by the MR of CH4, that is 16, multiplied by the Avogadro's number, that's gonna be this one. And then after getting the answer, I'm supposed to multiply this by 4 because one molecule of CH4, we have 4 hydrogen atoms. In one molecule of CH4, we have 4 hydrogen atoms because they're asking about the hydrogen, so that's why we are supposed to multiply this by 4. Otherwise, if they will be asking about the molecules, well, then we are not supposed to multiply this by 4. That's the concept. Because they are talking about the hydrogen atoms. So in the methane, we have 4 hydrogen atoms. That's why I'm going to multiply this by 4. That's why I'm going to multiply this by 4. Remember. Okay. So this is an answer. So can you tell me what's the answer? This is the formula. You can solve it. Then tell me the answer. Yes. Yes. Fast. Fast. What's the answer? Let me do this. It's 14 upon 16 multiplied by 6.02 times 4. It's gonna be C. Yes. So C is correct, right? Which structures represent a pair of isomers? Isomer is the one which is going to have the same molecular formula but different structural formula. So it has 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. Okay. So, okay, possibly it is A, but let me check all the options, right? 1, 2, 3, 4, 5. 1, 2, 3, 4, 5, 6. No. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5, 6. No. 1, 2, 3, 4, 5. 1, 2, 3, 4. No. So that's why. Oh, it's very easy question. Okay. Which molecule? Yeah, that's the one. Geometric isomer. What's the condition for the geometric isomer? There should be a double bond. There should be a double bond. There must be different groups attached on the same carbon atom. It's gonna be incorrect. You know why? Why? Same groups attached on the same carbon atom. Wrong, wrong, wrong. And this is gonna be correct. We have a concept. We can do this fast in a faster manner. What I told you that there are two conditions for geometric isomerism. Number one, there should be a double bond between the carbon-carbon atom, and different groups are attached. Different groups are attached on the same carbon atom. So that's why option D is correct, right? Which is the correct mechanism for the electrophilic addition reaction between HBr and pent-1-ene to give the major product? To give the major product. Major product is the one in which I would be having the positive carbon having the less number of hydrogens. Remember, having the less number of hydrogens. Okay. So major carbon is the one, major product is the one in which I would be having the less number of hydrogen atoms. Okay. So I have to see the options. So then I have to see the options. I can say that. Yes, 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 yes. Okay. This is completely wrong because always the negative species is going to attack on positive carbon. So this arrow, direction of arrow is wrong. This direction is good. This direction is good. This direction. But the thing is that I can say that uh, again, this is wrong. Positive is going to attack, right? So this and this may be correct. So we have to decide between B and D. Okay, we have to decide between B and D, right? So I can say that B for ball is correct. You know why? It's quite clear. You are supposed to only look at few factors. It must have a full negative charge, not the partial negative charge. Remember, it's a criteria. It must have a full negative charge. So that's why option B is correct. It must have a full negative charge, right? So that's why option B is correct.
Sir, how many entities are there in one paper?
Okay, then you can see this question is about carbon dioxide. Okay, according to the data from 2021, there are 415 ppm of carbon dioxide in the atmosphere by volume. Calculate the moles of carbon dioxide present in. Everything is given to you. This is the volume, this is the temperature, this is the pressure. Then we are going to apply the formula. P is equal to nRT. We have to find out the mole. That's going to be PV over RT. So P is the pressure, which is 101 into 10 raised to the power 3. It should be in Pascal. Then we have a volume. It should be in meter cube. It is. Then R is 8.31 multiplied by the temperature, that is 20 plus 273. It should be in Kelvin. It should be in Kelvin, right? It should be in Kelvin. So, so what would be the number of moles? Yes. What would be the number of moles? The number of moles should be 0.0172 mole. Okay. Then the dodecane is found in kerosene and forms carbon dioxide using during its complete combustion. What is mean by the term complete combustion? Complete combustion is the one in which the substance is burned in an excess of oxygen. When the substance is burned, when the substance is burned in excess oxygen. Write a balanced equation for the dodecane. Okay, C12H26 is reacting with O2 to produce carbon dioxide and water. Number of carbons are equal to carbon dioxide, number of hydrogens half of the water. So it's gonna be 26 is 1 and then 13. Then we have to balance oxygen. So it's gonna be 24 plus 13, yeah, 18.5. This is your balanced chemical equation. State symbols. Oh, okay. This is liquid, right? Oxygen is a gas, carbon dioxide is a gas, and hydrogen is liquid. Okay. Oh, it's of 6 marks. Kerosene is used as aeroplane fuel. A jet plane can carry a maximum of 800 passengers and uses 11,400 dm cube of fuel per hour. Calculate the mass in kilograms of CO2 emitted from the engine per passenger on a full flight from Sydney to Hong Kong. Oh my God. Flight time 9 hours and 15 minutes. Give your answer to three significant figures. Assume kerosene consists solely of C12H20. Okay. Okay. This is the formula for kerosene. Density of dodecane is 0.749 grams per centimeter cube. Okay. So basically, I have to find out the how much the fuel is used. How much the fuel is used. I'm going to apply. I have to apply the formula, right? So I can say that they have given you the volume of fuel per hour. Okay. So and also, I can say that in the question. Uh, or what they are saying. Yes. Okay. Okay. 800 passengers. Calculate the mass in kilograms of carbon dioxide emitted from the engine per passenger on a full flight from Sydney to flight time is 9 hours and 15 minutes. Give your answer to three significant figures. Okay. Oh, okay. Yes. So, yes, what do you think about this one to solve it? You can apply your concept. Then I'm going to tell you. This is very interesting question. This is very interesting question. Yes. Yes, 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 yes. Think about it. Yes, 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 yes. Then I'm going to tell you this one. Yes. Hmm. Okay, I'm going to tell you this one. First of all, I can say that I have to find out the uh, volume of volume of fuel, volume of fuel used, because they are saying per hour they are consuming 1400 decimeter cube, okay, per hour. And what's the total hours? 9 hours and 15 minutes. 9 hours and 15 minutes. Remember. So it's mean that I'm going to multiply this by 9.25. Okay. 9.25. So I would be getting 105, 105 and 450. Right? This is the total volume of the fuel used in a whole journey. Remember, because they have given you this much volume of fuel per hour. So I have found the total volume of the fuel that would be consumed in a total journey. Remember, then what I'm going to do, I'm going to find out the mass of fuel. I'm going to find out the mass of fuel. That's gonna be 105,450. Okay, decimeter cube, right? Or I can say centimeter cube because I haven't converted into the decimeter cube, multiplied by the density, that is this one, 749 grams per centimeter cube. So they will be canceling each other just like that. So I would be getting the answer, which would be the mass, which would be the which would be the mass basically, in fact, right? And else you can convert this into the, of course, like you have to convert it into a decimeter cube because I got the answer in decimeter cube. Yeah, I got the answer in decimeter cube basically, right? So the answer would be, I'm going to multiply this by 1000 as well. So the answer would be 7.8982 times 10 to the power 7 in grams. So this is the total mass of a fuel which will be consumed in a total journey, right? Then what I'm going to do, I'm going to find out the mole of fuel used. Mole of fuel used. That's going to be mass over MR, isn't it? That's going to be mass over MR. Okay. So, uh, or else I can write it down 78982, then triple zero. So I'm going to write down the mass 78982 divided by the molecular mass of this one. Okay, C12H22, that's gonna be 170, right? 12 times 6 plus 26. So it's gonna be 170. This is the mole, which is mass over MR. So I would be getting 464, then 600. It's the mole. It's the mole. Or else I can say that, or else I can say that, then I'm going to find out the mole of carbon dioxide. Since the mole ratio between this and this is 1 is to 12. Since the mole ratio is 1 is to 12. So C12, C12H26 and carbon dioxide is 1 is to 12. If I got the mole, that is this one, for the hexane, for the kerosene, so it would be X. So X would be equal to 464,600 multiplied by 12. So I would be getting the mole of carbon dioxide. That's gonna be 5,75200. This is the mole of CO2. Then I have to find out the mass of carbon dioxide. Then I have to find out the mass of carbon dioxide, which is Mr. Moles, which is nothing but Mr. Moles. MR of carbon dioxide is 44 multiplied by the mole, that is 5,575,200. It's gonna be it's gonna be 2.4531 times 10 to the power 8 grams times 10 to the power 8 grams. Okay, times 10 to the power 8 grams, right? So what they have given, total we have 800 passengers. Total we have 800 passengers. So what we are supposed to do, I'm going to divide by the total passengers. I'm going to divide it by the total passengers. So if I have the mass, that is 2.4531 times 10 to the power 8 divided by the total passengers, that are 800, the mass in kilograms. So I have to convert into the grams. So I'm going to divide the total answer by the thousand, isn't it? I'm going to divide the total answer by the thousand, which would be giving us the mass in kilograms. Approximately, the answer would be 306 around something kilograms. That would be your answer. So basically, all in all, if I can analyze this question, so I can say that there is nothing new formula in this. The only thing is that you need to know the concept. What time you are going to apply which formula. That's the concept basically. Nothing is new. But of course, like you have to see the question, you need to see the condition, okay? What's the scenario is going on in the question? So it will take your time, but of course, in the same paper, you will see some questions as well, which would be very easy, which would take your very minimum amount of time. Of course, so the time would be balanced. So don't worry about that. Like if we will be doing this question, so it would take a lot of time. So don't worry about that. You will see other questions which would be very easy for you. Trust me, okay? So basically the paper is almost balanced. It's not like they are not doing like dishonesty with the students. They first solve this, then they have to see whether the time is suitable for this paper or not. So they have to give the questions accordingly. Now you can see this question they are asking. The formula C12H26 represents many isomers. Of course, it has a lot of carbons, including 6-diethyl octanes. The names of 4 of these diethyl octanes are this one, this one, this one, this one. Draw the skeletal formula of the remaining 2 diethyl octanes. So the one which they have given to you, like except these things, you need to write down another one. So they have what the total number of carbon we have, the total chain, oct, 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 oct. The chain of 8 carbon atoms. Let me do this in an easier manner. 1, 2, 3, 4, 5, 6, 7, 8. So what they have told you 3 comma 3 like that. Then what they have told you 3 comma 4, right? What they have told you 3 comma 5. Then what they have told you 3 comma 6, isn't it? Now we have to write down something else. Something else. Okay. So uh, I can say that 4 comma 4, isn't it? Isn't it? I can write down 4 comma 4. This is the possibility. Of course, it's the possibility. Or I can write down 3 comma 5, right? Diethyl octane. Let's say first of all I'm going to draw the this one structure. Okay, so let me write down the chain of 8 carbon atoms like that. 1 2 3 4 5 6 7 8. So 1 2 3 4. So I can make the chain on the fourth carbon atom. It would be ethyl. It would be what? It would be ethyl like that. This is the first one. This is the other one. This is the other one. This may be the isomer of like the given formula. This may be the isomer of the given formula. I'm going to share my screen. Wait. Yes. Okay. This may be the possible structure for this question. Okay. And then what would be the another possibility remaining to diethyl octane? It should be diethyl. You can see this is ethyl. It's not methyl. It's ethyl. It has 2 carbon atoms, 1 and 2. It's not methyl. Remember, this is an important hint for you. This is an important hint for you, right? Or I can write. I can copy this one. I can copy this one and then I can change the position of the branch. Then I can change the position of the branch, right? I can do I can change the position of this one to this carbon atom. Yeah, I can do this one, isn't it? I can do this one. It's 4 comma 5. It's 4 comma 5, right? You can see, I'm going to count it. You can see this one. 1, 2, 3, sorry, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8. So the one which I did, it's gonna be 4 comma 4. 4 comma 4. This is not given, so it's the new possibility. And the one which I have, which I did, it's 4 comma 5. It's also not given. You can see 3 comma 3, 3 comma 4, 3 comma 5, 3 comma 6. So here is the new possibility. So you have to think about that, of course. No, this question is about ionization energy. It's very baby question. So calcium loses electron. Of course, calcium is going to lose 1 electron, then second electron, of course, it's in the second group, right? So I can say that calcium in the form of gas, when it would be losing, when it would be losing I can say uh, prawn, it would be giving you calcium 3 plus gas because they're asking the third ionization energy, right? Okay. Third means already it has lost two electrons, so now they are going to lose third electron. Deduce the reason, the identity of the element. Okay, okay, okay. We can see the big jump. We can see the big jump. I think the big jump is in between this one and this one. Right? It's 8,000 to 27,000. It's a big jump. It's a big jump between 6th and 7th. It's a big jump between 6 and 7. It's a big jump between 6 and 7. So I can say the group number is 6. So the group number is 6. When the group number is 6 and they told us the period number is 3, so we can go to the periodic table and we can match. So I will see that the element is sulfur. It's very easy. It's very easy. Or state the general trend across the period. So of course the general trend is increases. Ionization energy increases as the size decreases. It's very easy. Oh my God, now they are asking to, I think, explain the difference. Okay. Plot the following first ionization energies of the elements in period 2 on the grid below. Okay. Uh, Basically, it's an element. It's an element, right? And I can say that it's ionization energy. Ionization energy. I'm not going to draw this one, right? It was a lot of time, but of course, it's a very easy question. You will be plotting the curve. And then what they're asking, explain the difference in first ionization energies between beryllium and boron. Let's do some points. Lithium is 520. Lithium is 520. This is 400. It should be, I can say, 800. It should be, I can say, 1200. Then it should be 1400. Then it should be 1600. Right? And this is 2000. This is 2400. This is 2800. This is 3200. This is 3600. And this is 38. No, sorry, 4000. Okay. So, for lithium, I can say that it's 520. For lithium, I can write down the elements. This is going to be lithium, okay, beryllium, then boron, then carbon, then nitrogen, then oxygen, then heme, then neon. Okay. So for lithium, this is the point. For beryllium, uh, I can say this is the point. Okay. Or for boron, I can say this is the point. It's 801. Yeah, slightly up. So in the question, they were asking about that. Beryllium is higher and the boron is lower. Ionization energy for beryllium is higher and the boron is lower. Why? What's the reason? If you will be writing down the electronic configuration, so you will see the answer. So beryllium is 4 and boron is 5. One is 2s2. So this is partially filled, right? This is partially filled, right? So far away from the nucleus. It's more stable, and partially filled is less stable. That's the reason boron would be requiring the less amount of energy, and boron would be requiring the higher amount of energy because it's difficult to remove an electron from the stable orbital. That's the reason. You know why they are asking? Because across the period, ionization energy decreases. You know why are they asking? Ionization energy, sorry, increases across the period. So why the boron is lower? So it's an exceptional case. It's an exceptional case, right? So I can say that 2p is going to have a higher energy due to its partial solubility. It's higher in energy, right? So it would be easy to remove an electron. So that's why. Explain the difference in the first ionization energies between carbon and nitrogen. Carbon is 6, nitrogen is 7. It's 6, nitrogen is 7. So I can say that for carbon, 1 is 2, 2, 2p, 2. It's half filled. It's more stable. Less stable means less energy would be required. More stable means more energy would be required. That's why carbon is lower. Nitrogen would be higher, of course. Nitrogen would be higher. Okay? Nitrogen would be higher. And from both elements, electrons are removed from 2p. For both elements. But the thing is that, and also the size of nitrogen is lower as compared to carbon. Okay? Why the size is lower? Because nitrogen is going to have 7 protons in its nucleus as compared to carbon. When the number of proton increases, so nuclear attraction increases. When nuclear attraction increases, so the size decreases. Also, I can say the size of nitrogen is lower. Larger size. Smaller size and larger size. So yeah, it's nuclear attraction. Weaker nuclear attraction. Right? Okay. So